Hello, I'm going to talk you through a couple of relationships that have what we call inverse proportion. So the first one is imagine I have a rectangle and I know that the rectangle has an area of 24 centimetres squared. There are actually loads of different possible rectangles I could have with different dimensions. Pause the video for a moment and have a think about what different possible dimensions they could be. And once you've come up with some ideas of what they might be, think about what would you get, what sort of shape you'd get if you were to plot the length and the width of those different rectangles you found, plotted them on a pair of axes. Okay, so here are a few examples of lengths and widths we could go for to make our rectangle have an area of 24. We could go for 4 centimetres and 6 centimetres. We could go for 2 centimetres and 12 centimetres. So we're making sure that our length and our width multiplies to make the 24. We could go for 1 and 24. We could go for 3 and 8. And you can also go for decimals and fractions. You don't only have to go for integers. So for example, I could go for 0.5 and 48. Okay, so there's a load of different values you can come up with there. You'll notice that as one value gets bigger, the other one gets smaller. So if we look at this rectangle and this rectangle, hopefully you can see that this one gets doubled and this one has to then half, so that the product of them still gets you the 24. Okay, so you can see a little pattern going on there with those ones. If I were to actually plot them, let's have a think about what that would look like. So let's say I plotted my 0.5 and my 48. That's going to be very, very short distance along, really, really high up. Okay, next one, if we went for 1 and 24, well, it's going to be twice as far along, but half as high up. So it's going to be about there. Next one, let's go for 3 and 8. That one is going to be, let's say, about there. And you'll end up, if you plotted your different points, sorry, it's not drawn that brilliantly, you end up with a shape that looks like this. It's actually called a rectangular hyperbola. It's not called rectangular because of the rectangles, but it just so happens that in the case of this example, we have rectangles and we have a rectangular hyperbola. Okay, I'm going to show you another example of inverse proportional relationships now. Turn the board. So hopefully you are familiar with the formula speed equals distance divided by time. Let's have a think about some possible speeds and times that could go together if we had a fixed distance of 60 miles. So we know we're traveling 60 miles. We need to think about some different speeds we could travel and the times it would take me to get that distance of 60 miles. Again, pause the video for a minute, have a think about the different possible values you could have as pairs for speed and time, and then play the video again in a moment and I'll talk through a few of my ones. Okay, so I'm going to go through a few different options then for our speed and our time. Let's start off traveling quite slowly. Let's say we start off going at 10 miles per hour. So for every hour that I'm driving, or walking, running probably, every hour that I'm traveling, I'm going 10 miles. So it's going to take me 6 hours to get 60 miles. Okay, let's go a bit faster now. Let's double our speed. Let's go at 20 miles per hour. So it's going to take me 20 plus another 20 plus another 20, 20 miles each time. So that's 3 hours. Now let's go at 30 miles an hour. So with this one, once I've travelled for 1 hour, I've gone 30 miles, which is half my distance. So I've got to do it again. So 2 hours is how long I need. 60 miles per hour. Well, the clue's in the name, miles per hour. If you're going 60 miles per hour, it's going to take you exactly 1 hour to do 60 miles. Let's say I'm going 120 miles per hour, which I would never do, of course, if I were driving. But if I was going really, really fast, 120 miles per hour, I would get there with only half the time. It'd only take me 30 minutes or half an hour. Now let's think of something that goes super speedy. Let's say we're going 600 miles per hour. Okay, so we're definitely not in a car at this point. Okay, so we can go 600 miles in 60 minutes. So in order to go 60 miles, I can divide by 10, and it's only going to take me 6 minutes, or 1/10 of an hour. Okay, so if I go 600 miles per hour, it's going to take me 1/10 of an hour. What you should notice with all of these pairs of values that we have here is that if you times the two values together, you will always get 60. 10 times 6, 20 times 3, 30 times 2, and so on. You're always going to get 60. Okay, so we can say that in this case, k is 60. There's a constant value k that you always get when you times these two together. Hopefully that makes sense to you in this example, because looking at this formula, if I times both sides by time, I'd have speed times time equals distance. So if we set the distance as 60, our speed and our time have to multiply together to make that distance. Okay? So those are two examples of inverse proportional relationships to introduce you to how this topic works. There are actually loads of other different types of inverse proportional relationships that you can get whenever you have a relationship that has division, or if you rearrange it, timesing. Okay, so have a little think what other formulas you know from maths or from physics could also generate for you an inverse proportional relationship.